This is Tonopah, Nevada, which in its more active days was a gold and silver mining center in the mountains of west central Nevada. It is now a tourist stopover on the Reno to Las Vegas highway. About 40 miles southeast of the town of Tonopah is Sandia Corporation's Tonopah Test Range, which encompasses about 637 square miles of rangeland and alkali lake beds, normally dry. Originally established as a bomb-dropping range, Tonopah Test Range has gradually developed into an outdoor laboratory facility. Test range operations center at the control point, which houses range, electronic, and administrative controls. Whether the unit under test is a bomb dropped from a high or low-flying aircraft, an experimental rocket thrusting aloft a test unit for detailed study, a balloon lifting a test shape to the edge of atmosphere, or a component being subjected to the high acceleration and stopping forces of a controlled field artillery piece, a network of range instrumentation feeds control and data information on these tests to the range console, from which control of all range operations is maintained. The control point maintains radio contact with Sandia Laboratory in Albuquerque, with range guards who maintain personnel and information security on the range, with each of the range instrumentation stations, and with the pilot of the aircraft delivering the test shapes. For all tests, weather information is obtained at ground level and at various altitudes. A radio sonde is attached to a weather balloon, which is released shortly before the test. As the balloon rises, the radio sonde transmits weather data to this ground-based receiving equipment. A record is automatically made of wind direction, wind speed, air temperature at various altitudes, density of the air, and relative humidity. As the aircraft approaches the range for a test ballistic drop, the pilot contacts range control radio. He gives range control his location, heading, altitude, and speed. This information helps radar operators lock in on an airplane which may be several hundred miles from the range. The distance measuring radar indicates azimuth and elevation. This information is fed to optical instruments on the range to help them lock on to the approaching airplanes. As the aircraft approaches, tracking control shifts from radar to manual tracking by the optical instrument operators. As the test shape falls, its every action is recorded by a variety of optical and electronic instruments. The cine-theodolite combines the abilities of a precision surveying device with the memory retention of the motion picture camera. The resulting film records from several cameras are combined to determine the exact trajectory of the falling unit against a time record which was recorded on the film as the test proceeded. High-speed motion picture cameras photograph the behavior of the falling test unit using Sandia-designed telescopes as lenses. These photographs of the unit are studied by the design and development engineers of Sandia Corporation to determine weapon stability in flight, conditions as the parachute opens, and other flight characteristics. The flight path of the aircraft and the trajectory of the test ballistic shape can both be documented electronically by this complex known as MIDOT. Radio waves from transmitter units within the test specimen are received by these precisely located antennas on the ground. Through the interferometer technique, the MIDOT system determines trajectories by computing cosine angles and their functions. Output of the MIDOT system is permanently recorded for later study in correlation with other trajectory data from the drops. Before the unit is airborne for testing, telemetering systems are installed. These electronic networks, which have been developed and refined over the years by Sandia engineers, ride within the units to radio vital data to ground receiving stations. As the unit drops, separate internal transducers sense conditions experienced by the test unit. This valuable information is recorded at the range control point on multi-channel tape recorders and becomes a permanent part of the test data. Devices within the unit transmit to ground receiving stations details of acceleration, vibration, internal temperatures, roll, pitch, and yaw, external temperatures, pressures, strains on internal components, and on the case of the unit. The target for airdrops is centered on a large dry lake bed 7 miles from the control center. Near the lake bed target is a hard target, a concrete X, 750 feet long and 250 feet wide. Surrounding these targets are additional photographic installations. This CZR camera is one of a group of fixed cameras having overlapping fields of view which cover the entire hard target area. The photo records of these cameras yield angle of impact and impact velocity measurements, which are particularly valuable in recording low-level drop information. The 70mm motion picture cameras are another group of fixed view cameras used on hard target tests to photograph trajectories. These and other range cameras are furnished a digital time signal, which appears on the film as a time base for subsequent reduction of data. The 35mm cameras are mounted on pedestals which allow the operator to follow action. Running at high frame rates to slow the action, they are hand-operated to acquire documentary coverage of selected events. Near the lake bed target is the Tonopah Test Range rocket launch facility. Rockets launched here have served a number of weapons programs, in many cases relieving aircraft for use on other defense and training missions. Rockets can boost test specimens to higher speeds than those attained by present airplanes, making advanced tests possible well ahead of the availability of newer aircraft and larger intercontinental rocket systems. When required, rugged motion picture cameras are mounted directly to the unit under test, in this case, a rocket. Triggered automatically just before blastoff, these cameras photograph events occurring throughout the test. Behavior of the booster at breakaway and parachute deployment can be observed and studied in this data film record. The lake beds of Tonopah Test Range are also suited to balloon launches. Range weather information stations, camera installations, and long-range radar combine to create controlled launch environments. High-quality film records of balloon flights and full knowledge of the balloon path as it soars to high altitude are assured by these instruments. An artillery rifle and 2 howitzers are used on the range for high acceleration and deceleration studies. These field pieces have been instrumented to allow high-speed photography within just a few feet of the muzzle. Other range instruments follow and record complete trajectories. This, then, is Tonopah Test Range, a precisely instrumented outdoor laboratory where Sandia Corporation engineers and technicians combine the science of optics and electronics with human skills to supply the data of modern weaponry. This data yields the vital information of test weapon performance essential to the continued development and improvement of the nation's nuclear defense.